Okay. So that is a one point. I think in the last session, I just told up to partitioning by, and we have discussed about all. So in the today's session, first I would like to explain what is parallel stream. Of course, here I need to add some methods and the source code also I will add here. Then I will update the document. But so I can add some statement over here, and that is called about working on parallel stream. So just we want to know like how does parallel stream work? The thing is, how does parallel stream work? Right, okay. Just what parallel stream will do. Parallel stream is nothing but actually it is another new feature of Stream API. So by using it, we can process the elements of the collection on multiple CPU cores to make it faster completion. It will utilize multiple CPU cores. In parallel, it will process the elements. That's why it is called parallel stream. Okay. There is a method available that is called parallel stream. So let's see what parallel stream will do. Okay. In stream, it is another new feature. In Stream API only, it is another feature of Stream API. What will happen now? It will process the elements of a collection on multiple CPU cores so that it can be completed fastly. So how it is going to be? It will split the collection or workload. It will divide into multiple tasks and it will execute them concurrently on multiple CPU cores. Suppose you have a collection of 1000 elements and you are performing filtration operation. It will split the 1000 elements of a collection into multiple tasks. Otherwise, we can say them as chunks. The word chunk is important. Okay. It will divide them into multiple data chunks. Let's say two data chunks like 500 elements and 500 elements. Let's assume that. Then it will start processing the 500 elements on one CPU core, another 500 elements on other CPU core. And once the processing is completed, it will join the result coming from CPU core 1 and the CPU core 2 will join together and will give us like a final result. Okay, so diagrammatically, suppose if you want to understand about how the parallel stream work. There's a one point missing out in the last session we have not discussed due to time constraint. And today I just want to first explain that parallel stream operation. Then we will discuss about concurrency API. Okay, so there is a date time API. I will provide them in the document with a detailed information. And you can simply go through and you can understand that. Okay, so no need of getting much explanation for date time API. I will give you an overview. Okay, see here. First, let me tell you some of the points here. The points I want right here is parallel stream is it is another new feature. Otherwise, we can say it's a feature of the Stream API. Parallel stream is a feature. Is a feature of Stream API. Right? Parallel stream is a feature of the Stream API. Now, done. So, what's the other point I wanted? It will process the elements. It will process the elements. Right? It will process the elements of a collection parallelly on multiple CPU cores. multiple CPU cores. Okay, it will process the elements of a collection parallelly on multiple CPU cores. That's what the parallel stream will do. So first it will divide and then it will join. So it internally uses a concept called as fork join framework. Okay, fork join framework is a feature. Actually, it is from Java 7. It uses internally the concept name called fork join framework. Means first it is going to divide the workload onto multiple tasks and will execute each task on different CPU cores. Then will join the results coming from all the CPU cores. That's called fork, then join. That's why it is called fork join framework. Okay, that fork join framework will do the same. It internally uses the fork join framework of Java 7 actually. That fork join framework is from Java 7. So this Java 8 feature internally uses that Java 7 concept. So I would like to, explain the point like this. See, for example, you have to visualize like this. Okay, let's say you have some. Let's consider you have 1,000 elements in a collection. You have a list of, let's say, you have a list of 1,000 employees. Okay, and your requirement is you want to do some filtration. Your requirement is you want to perform some filtration. The filtration could be the employees having passports, or the filtration could be with a salary more than $4,000, or filtration could be female employees or male employees. So like that, you have some kind of different requirements are available here. You have a list of the 1,000 elements, or could be even more better, but okay, let's take 1,000. Requirement is you want to perform filtration. What parallel stream will do, it will divide this data into multiple tasks. Let's say task 1 will execute on a separate thread. For each task, it will span one thread. It will create one thread. It will divide it into multiple tasks. Task 1 is execute filtration on 1 to 500 elements. Filter, let's say 1 to 500 elements. Task 2 is filter, let's say 501 to 1,000 elements. Like this, task 1 and task 2. Task 1 is filter 1 to 500 elements. Task 2 is filter 501 to 1,000 elements. When there is a list of 1,000 employees, requirement is perform filtration. Task 1 is filter 1 to 500. Task 2 is filter 501 to 1,000. Okay. Like this, it is divided into task 1 and task 2. And this task 1 will execute on one CPU core. Will execute on one CPU core. Let's say CPU core 1. And now this is going to execute on CPU core 2. Right? Task 1 is executing on CPU core 1. Task 2 is executing on CPU core 2. Now what happens now? After executing the task 1 and task 2, both of them, task 1 and task 2, are combined together and will give us like a final result. We are good. It is going to join. First, it is going to fork into two tasks. Fork task 1 onto CPU core 1, fork task 2 onto CPU core 2. And then next, it is going to perform. Okay, first filtration will happen. After that, it is now going to join, and we are going to get the final result. So parallel streams are going to work in this way. Okay, that's why parallel streams will make faster execution, will improve the performance. And here it is going to use a concept called as join. And while dividing this task into multiple tasks, this is called forking. So it is just going to divide a task into multiple tasks to execute each chunk. This is called one data chunk. This is called another data chunk. It is going to divide the actual data, the whole data into data chunks, and will execute each chunk on different CPU cores and will join them together to get the final result. This concept is called parallel stream, so that it can able to make the faster execution and definitely will improve the performance, especially when we have a some millions of records or elements are there to process. Then parallel stream will be the better option. So let me add some statements here. So just we are going to call one parallel stream method. We are not doing anything explicitly. Instead of calling stream, just we are going to call parallel stream. That's it. Okay. So what parallel stream will do now? It will split parallel stream will split the data into multiple data chunks. Will split the data into multiple parts. Parts means data chunks. Will split the data into multiple data chunks. Executes each chunk on a separate CPU core, and then joins the results of multiple CPU cores, joins the results of multiple CPU cores and returns the final result. So that's how it works. That's how it works. Okay, this concept name is called parallel stream. This is called parallel stream. Okay, so we need to call parallel stream method on a collection object. Instead of stream method, just we are going to use parallel stream. Okay, so we have sequential stream and parallel stream. Okay, if you create a stream method, it is called sequential stream. If you call parallel stream method, it is called parallel stream. Sequential stream will perform the operation on one CPU core, but parallel stream will perform operations on multiple CPU cores by utilizing the full potential of the CPU. So you can analyze like sequential stream means like, there is only, one chef is cooking all the dishes. Parallel stream is nothing, multiple chefs work simultaneously. So that preparation time will be very less. The same concept here. Okay. Right. Right. Just okay. We are just going to look into a simple example, and then we will conclude. We will take up the previous example. But what's the method I'm going to call is dot parallel stream method. So what I can say is that parallel stream internally uses fork join framework. Actually, fork join is a feature. Okay, simply we are, it is a feature of Java 7. Feature from Java 7. from Java 7 plus. Fork join framework. It internally uses this one. And what's the method to call is parallel stream. So a parallel stream can be started or can be created anything. A parallel stream can be created by calling parallel stream method on collection. Parallel stream method on collection object. A parallel stream can be created by calling parallel stream method on a collection object. Okay, that's how it works. Now let us see. Let us see a piece of example code in which we can understand. Let us consider our previous example only. Just we are going to start the IDE. First, we will do one thing. We will just check. Let's say, for example, using stream, how much time is taken, and using parallel stream, how much time is taken. And so that we can just understand whether parallel stream is going to give a faster execution or not. Okay, let me show you the code. So these are all the things that we have discussed yesterday, and let us keep all these in comments. See, what I will do, I'll go to this service class and I create one more static method here. First, I want to get all the list of employees. It is a parallel stream operation. Okay, public static. Actually, I do not want to return anything. Simply say void. Simply say void. It is just only a parallel stream demo. My method name is a parallel stream demo. First, we want to get the list of employees, and that's the common statement that we want. Okay, I have a list of employees. Employees is equal to get employees. I got a list of employees. And after I got the list of employees, what should I do is, right? After getting the list of employees, what should I do is, I would like to, okay, just look at about the sequential normal stream operation. Just to, we will do one thing, just only we want to print them. Okay, because we want to use a system for each method of stream API, and just we want to print that particular element, that employee. That's it. Okay, right? And at the same time, I also just want to show you that which thread is actually printing it. That thread current name I can get right, so I can use that. But at the same time, I also want to calculate how much time is taken to print out. Just print one by one employee using stream operation, just using normal stream operation without using any parallel stream operation. It's called a sequential processing. Okay, how it is going to be? I first want to call stream, and then I want to call for each to display. That's it. Because stream also contains for each method. For each is a method available in all collections, and for each method is also available in stream. Now, for each method takes consumer object as parameter. So you know how to define a lambda expression for a consumer interface. So what I will do, I will just write. Okay, I will just write. Okay, employees dot stream dot for each. Okay, let me call line by line so that you can understand. Directly for each method I want to call. For each employee, I want display, but I want to display the thread name also. So system.out.println, the thread who is printing it. So to get the thread name, I can call the method called as thread.currentThread.getName. This is the way to get the current thread name. Then just give some hyphens, then print that employee. This is sequential processing. Now, instead of a stream, I can call parallel stream. Same code, but just only in place of stream, I want to call what? Parallel stream. Now, I want to put the heading, and the heading is parallel processing. In the comment, employees dot stream. Sorry, we don't want stream, right? We want parallel stream. So we are having parallel stream, then dot for each, same code. The same lambda expression I want to provide. Okay. This method I want to call from main, of course. It's a static method. I will call directly with the class name employee service dot parallel stream demo. Parallel stream demo. I can able to call that. But the thing, how do I know that parallel processing has better performance than sequential processing? Parallel stream response is faster than stream response. Let us calculate how much time is taken to process this instruction or to execute this piece of code. And let us also calculate how much time is taken to execute this piece of code. Then we can see the difference. We have a method in system class called nano time. We have a method you know what I can say, nanosecond. Nano time means it is approximately 1 by I think 1 by 10 lakhs time of millisecond is a nanosecond. Okay. Or otherwise, we can directly call the method called current time millis. At least we want to get milliseconds only. No? Definitely, it will take some milliseconds. Right? So there is a method available called current time millis method is there. So that method we will call long. Let's say start time is equal to system dot. We have a method called current time millis. We also have a method called nano time. We have a method called current time millis. Returns the current value of the running JVM high resolution time source in a nanoseconds. Okay, this is going to return the milliseconds. Returns the current time in milliseconds. Okay. So let's call current time millis. Otherwise, let us talk about nano time. Start time, then end time. After processing, long end time is equal to. Again, system dot current time millis. This is for stream sequential processing. And of course, I also want to show the message here. Okay, how much time is taken? That's end time minus start time milliseconds. So SOP, sequential time or stream time and parallel stream time. End time minus start time. Plus milliseconds. MS. Okay. Next, coming to parallel stream processing. Let us consider again start time, again end time. Already it's declared as a long variable, so I'm utilizing the same variable. Start time is equal to system dot current time millis. Again, end time is equal to system dot current time millis. And then I say SOP, this is going to be parallel stream time. So it is again going to be end time minus start time. Plus MS. Okay, we have the start time and we have the end time. So end time minus start time. So let us call this operation parallel stream demo. This method we want to call from main. It's a static method, so we can directly call employee service dot employee service dot parallel stream demo. Let's run this code. We'll check how much time is taken to process it. So as you can see how faster it is. Okay. Stream time taken is 62 milliseconds. That's a stream time. But the parallel stream time is just 11 milliseconds. Now you can understand how parallel stream is a good one when compared with the stream. I mean, especially when there are large number of elements to process. Okay, in this way, you guys can understand that. Right? You guys can understand that this is the process of, the parallel stream operation. Okay. This is 11 milliseconds and this is 62 milliseconds. See how much difference we have. Right. And here there are totally, 7 employees. And here also we have 7 employees. Here all the employees are, the thread is main. There is no new thread, only one thread is processing all. But this is a parallel stream responsibility. In parallel stream, you can see there are different threads. Main thread is doing some work. And there is a common pool worker 1 is one thread. Common pool worker 2 is another thread. and a common pool worker 3 is another thread. So it is dividing into multiple tasks, and each task is executed by one thread. Main is doing some operations, main thread, worker 1, worker 2, worker 3. Okay, that's why I have displayed the thread name also. At least you can understand whether each task is going to be executed by a separate thread or not. So we can show the thread name, and that by that we can understand, yes, it is done by a separate thread. Okay, so this is a small code, a piece of code. What I will do is just directly I'll keep this piece of code in the doc. To understand about how the parallel stream is working. Okay, so you guys can see this, and we will move on to the topic now. Our requirement is now we want to just first understand about there is a feature in Java 8 called completable feature. Yes. So we'll understand about what is completable feature. Okay, right. But to understand completable feature, little bit of threading concept is required, multi-threading concept is required. So I will just explain about how completable feature works and how it is different from future object of Java 5. Then we will look into that. Look at this. The next feature which we want to start is completable feature of Java 8. Completable feature. Okay, right. We are going to look into completable feature. From the package called java.util.concurrent package. Okay, there is a class newly added from Java 8 called completable feature, and it implements future interface. Future is an interface, completable feature is a class. So we are going to understand this is from Java 8. If you look at future, future is from Java 5. You can say since Java 1.5. This is interface called future. But a completable feature is a new class which is added since from Java 8, version 1.8. So we are going to look into first completable feature. So here we are going to understand a little bit concept. So let's understand about completable feature class. Completable feature class is what our discussion now. Okay, let's start. Here, a bit of multi-threading knowledge is required. This concept is related to multi-threading. Okay. Actually, there is a framework given called executor framework. Executor framework is nothing but it is not a big thing. Executor framework is nothing but it is an high-level API on multi-threading. To simplify the multi-threading concept in Java, multi-threading functionality, one high-level API is provided, and that high-level API is called executor framework. I'll tell you why. So what this executor framework will do is, it will simply will manage and will control the execution of the threads. They will manage the threads and they will control the execution of the threads. That API will do that work. And to manage and to control the execution of the threads, there is one high-level API is provided, and that is called executor framework. So why executor framework is given? Executor framework is not new. Executor framework is given from Java 5 version. Before Java 5, we don't have an executor framework, okay? From Java 5, this new framework added called executor framework into Java. Okay. So what is the purpose? It is just one high level API is given to manage the and control the execution of the threads, the thread execution, so that multi-threading concept gets simplified. That's what the point. So how and why we are going to understand that. It is not new. Completable future class is new, and I'll tell you why this is given. We will come to this point first, but we are discussing about background. The background is there is a framework called executor framework. The background is we have a framework, and that is called executor framework. So it is added from Java 5 actually. So executor framework. Okay, was added in Java 5. To simplify the multi-threading. Right. The executor framework was added in Java 5 to simplify the multi-threading and to manage and control the thread execution. Right. To manage and control the thread execution with an high level API. That's a point. This is called the executor framework actually. So let's see first of all why it is given. It is an high level API which is working on top of multi-threading. That's what the point of executor framework. Okay. So we are going to first before Java 5, what happened? We have to create the threads, and we have to, if I want to create the thread, I have extends thread class or implements runnable interface. Okay. So we have to create the threads, and we have to start the threads, not only just creating them. And if you want to stop a thread in the middle, then you can stop by calling stop method. We have methods like start, stop, and thread logic we can define in run method, and we have yield method, we have join method. So many thread operations are there. Okay. So developers have to create the thread, have to start the thread, have to stop the thread. All the manually thread management should be done. Right. And suppose if you are creating too many threads, which are more than required, then it is nothing but consuming more resources. Suppose, synchronization concept in multi-threading to avoid deadlocks. Okay. If you want, you have to manage the synchronization manually. If you manage the synchronization manually and correctly, then only you can able to prevent deadlocks. Otherwise, it may lead to deadlock. Right. And if you are not handling the synchronization manually, then your application will produce unexpected behavior. So that is actually called as a race condition. Two threads at the same time can access the shared resource and can produce data inconsistency problem. And that is basically called race condition. So we have to manually implement synchronization to avoid this kind of race conditions and also even to avoid deadlocks. These are all manual work. Okay. So one is manually you have to do the management of the threads, like you have to create the threads, you have to start the threads, you have to stop the threads. And if you are creating more than required threads, too many threads you are creating, then it will be like uh, consuming more systems resources, right? More resources, consuming more resources. Right. And the other point is like you have to take care of synchronization manually in multi-threading, and if it not done properly, then it may lead to deadlocks or potentially race conditions. So these are the issues that we have with the manual thread management. So that's why executor framework is given in the package java.util.concurrent. So what happens with the executor framework is it is separating. It is separating the thread creation logic from the remaining things. Means you no need to manually apply the synchronization. Okay. And you no need to manually only thread logic you need to define. You need to supply the logic. It will take care of creating the thread, starting the thread, stopping the thread, how many threads required. And it will avoid race conditions or deadlocks. The executor framework, that API will take care of all these things, creating the threads, starting the threads, stopping them, or synchronization issues, and how many threads required. It will take care of that. It will not create too many threads. At the same time, it will not create too less threads. As per the demand, it will create. So that's where the executor framework is given. What you need to do is just you need to submit your task. What's the task you want to execute in a thread? The remaining all thread creation process will be completely taken care. Thread creation process, execution process, everything will be taken care by executor framework. Just you need to submit your task definition. That's it. If you give your task definition to executor, executor will span a thread, means creates a thread and will start executing it. Will take care of synchronization, will take care of creating the thread, starting the threads, stopping the threads. Everything will be done by executor framework. That's why there is a good importance is there for executors. Okay, so I have explained, but I need to add some statements at the same time. I will add them. I can say before Java 5, programmers have to manually or developers anything, programmers have to manually create and manage the threads. Okay, before Java 5, programmers have to manually create and manage the threads. How the programmers can create and manage the threads is by using thread class and runnable interface. Okay, so the problems here are like developers have to manually manage the threads, nothing but thread management. Developer have to take care of thread management. Thread management means what? Creating the object, not only just defining the task inside a thread. So you have to create the thread, you have to start the thread, you have to stop the threads like that. So the problems are like developers have to create, start and stop the threads. We can say that developers have to take care of synchronization manually, take care of synchronization. And creating unwanted threads will consume more system resources. And creating too many threads will consume more system resources, right? Developers have to create, start and stop the threads. Developers have to take care of synchronization manually. And creating too many threads will consume more system resources. Okay, that's how it works. That's how it is going to be. Creating too many threads will consume more system resources. So Java 5 has introduced in executor framework, where a developer has to define the task. Okay, developer just have to define the task and developer has to submit it to the executor. And it will take care of thread creations, executions, everything. Developer has to define the task and has to submit it to the executor framework. You have to define the task and you have to submit it. What is the task you want to execute for a particular thread? You have to define the task and submit it. As to submit it to the executor framework. The thread creation process, execution process, that all will be taken, synchronization, everything. The rest of the work, like creating the threads, executing the threads, synchronization, etc. Synchronization, etc. Okay, will be taken care by executor framework only. Will be taken care by executor framework only. Are you getting my point? It will be taken care by executor framework only. That's why we need executor framework. Now, that the root interface or the top interface of executor framework is executor interface. It's a base interface, and directly we don't use executor, but we have another child interface called executor service. So that interface we are going to use. Okay. There is the base interface called executor. And there is a child interface extending executor that is called executor service. And that contains more additional methods. And there is a class available called executors class. So these are the three things to understand importantly. Only three. One is executor, second is executor service, and executors. Executor is a base interface, the basic interface. Executor service extends executor and will have the additional operations to manage the tasks. For creating different types of basically executors internally use thread pools concept. So for creating executor service objects, there is a class available called as executors class. It is a class. It is a one kind of utility class which contains static methods, and of course we call them as factory methods, and that can create an executor service object. That can create an object of type executor service. So there are three things to understand here. One is executor interface, and second is executor service interface, and third one is executors class. So these are the key components of executor framework. The key components of executor framework are executor interface, of course, it is the base interface or basic interface. Executor, it is a basic interface. Executor service, which extends executor. This is what we use, executor service. Executor service is an interface, and it extends executor interface. Executor service interface extends executor interface. And there is a class which is a executors class, which is a utility class. Executors class, and this is a utility class, creates executor service objects. Executor service instances, better word. Executor service instances. These are the three key components of executor framework: executor interface, executor service interface, and executors class. These are the three key components. Yeah. Each thread that is created to process the work by executor, that is actually called as a worker thread. There are different types of executors are there. I mean to say executors utility class has given some factory methods. We can say static factory methods like single thread executor, fixed thread pool, and cached thread pool. Like that, it has given three static factory methods. So we have a difference between one of the other. And there is also one thing called scheduled thread pool. So we are now going to look into, first of all, what are the static factory methods of executors class? These are called types of executors. There are some types of executors. Let us see who are the types of executors. There are four methods are there in the executors class, which is an utility class which can create executor service instance. So first we should know them before we start how to use executor to submit the task, and then how can we get the result. There are four types here. First one is a single thread executor, means it will only create one thread. Basically it is like, executing the submitted tasks one after the other. For example, I am submitting two tasks to executor or executor framework, because I am responsible for only submitting my task to the executors. Executor framework is responsible for creating the threads, executing my task in that thread, and it should produce me the result, and it should take care of everything, like rest of the work, synchronization, and it should avoid the deadlocks. Everything will be taken care by that high level API that is called executor framework, right? So uh, if, for example, I am submitting two tasks, it will execute one by one after the other, right? So that is called single thread executor, right? So this is one type of executor object. So I'm just going to talk about the types now. That is one type. So let me, write the step like this: executor service. How to submit the task, I'll tell you. Executor service, let's say service is equal to executors dot new single thread executor. This is a method. So how many are created executor service? Let's say service is equal to executors is one class. There is a static method called a new single thread executor. It is a factory method which creates instance of executor service. So it will just create a single thread. If one thread dies, new one is created. So this executor, if I'm submitting two tasks to executor service, I'll submit my task to execute service. If I'm submitting two tasks, then one thread will be created for executing task one. That thread will die. Now next one more thread will be created for the task two, and that will die once the task is completed. So means what? Once one thread is gone and the other thread is created. But at a time only one thread will be created. If the tasks are more, that many number of threads are created, but tasks are executed sequentially, one after the other. So creates a single thread. Creates a single thread. And processes the task sequentially. That's how this will work. And the other point was, if one thread dies, then the new one is created. Or we can say that the tasks are, this executor service will execute the tasks one after the other. suppose if two tasks are submitted to the executor service, I'll tell you how to submit. There is a submit method available. We'll do that. If two tasks are submitted to the executor service, suppose if two tasks are submitted to the executor service, then it will execute. Then first one thread is created. First one thread is created to execute task 1. After that thread dies, another thread is created, or a new thread, another thread is created. Okay, another thread is created to execute task 2. Like that. That is called single thread. Mostly it is not used, but this is one type of executor. That's the first category. I'll tell you, there is a method available called submit. By that, we can submit our task, but thread creation, execution, all these things will be taken care by executor service only.
Sir, the
Okay.
task is
In
given
executor
to the
service, we
executor
have a method
service.
called execute, and that we will discuss. Coding we'll discuss next. First, I want to just only explain
Sir,
what
I
the
have one
different
doubt
types of
here.
executors.
Sir, I have one doubt here.
Mhm.
Sir, you are submitting the task to the executor service. Executor service is an interface, right? We have to submit the task to executor class, which is providing the method.
Can you come again? I didn't get your question.
We are providing the task to the executor service, which is an interface. But we have to provide the task to the executor class, right? Because it is providing the method.
No. There is a factory method. Oh my God. There is a method, method. Factory method means what? It will produce an object. When you call connection dot driver manager dot get connection statement, for example, if you know in Java, it returns an object of type connection.
Yes, sir.
Executors class and executor service are not, like implemented class. That's why it is written as utility class. Executors is not an implementation class of executor service. Executors class is a utility class. It has methods which can produce an object of type executor service. Like
Okay.
in Java Stream API, collector. Let's say collector is equal to, I'm writing collectors dot counting. What does it mean? Counting is a static method. It is a factory method. Of course, it's a static method, static factory method. This method has a logic to produce an object of type collector. But a collectors class is not an implementation class of collector. Collectors is one separate class, an individual class, independent class. It is not an implementation of collector. Collector is an interface, a separate interface, individual interface. This is individual class. Both are different. This is interface, this is class. And this is individual class, this is individual interface. But in this class, there is a method available. That method returns an object of type collector. That's why whenever you call the method, you will get the result into, or you can store that result into an object of type collector. You can store in an object reference. This is independent class.
Okay, sir. Understood.
Okay. This is interface. Okay. Let me write so that other guys can also get if you have the doubt. Interface. Both are independent. This is independent. This is independent. Okay. Similarly, executors also same thing. Executors is an independent class. Executor service is independent interface. But in executors class, we have some factory methods that can produce an object of type executor service. So now, let's consider second example, executor service. These are the types of executors you need to answer in the interview. Executor service. Executors is again utility class. There is a method available called new fixed thread pool. This is called fixed thread pool executor. Of some number we need to provide. Let's say, for example, if I say 3, it will create 3 threads. The tasks may be 10 or 20, but it will create only thread pool of only 3 threads, and the 3 only will serve to complete the 20 tasks, like that. This is called one other category. Some number actually pass n can be 2, n can be 3. Okay, if n is 1, it is equal to the single thread executor. N should be greater than 1. Otherwise, you can use new single thread executor. It is going to create a fixed number of threads. If you have some fixed number of parallel tasks, controlled number, not very huge number, control number of parallel tasks, and then we can go for fixed thread pool. This is called second way of creating it. So it creates, this is another type of executor. So this is, it creates a fixed number of threads. And this fixed number of threads will be used to process or to execute the task submitted. That fixed number only. Suppose the fixed number of threads are 5, but I have tasks of 20. These 5 threads only will be used to complete the tasks of 20. So whenever first 5 tasks are done by 5 threads, if one task is completed, that thread becomes free. So that is going to take care of 6th task. Similarly, out of 5, if anyone is completed their task, that is going to handle 7th task, like that. So overall, the given number of threads only will be created, not more than that. Exactly that number of threads, but those threads only we are going to perform the task parallelly. That is called creating a fixed number of threads. Right? How you can understand this? For example, you take restaurant which contains 5 cooks or 5 chefs, fixed. Those 5 only will take care of preparing all orders. So these 5 are preparing, let us say, 5 orders at a time currently. If, for example, no chef is free, then the 6th order should wait. Out of 5 chefs, if one chef has completed his order, then he will handle the 6th order. If there are 8 orders, but 5 chefs are currently busy with the 5 orders preparing the food, then the remaining 3 will wait. And if, for example, one chef has completed preparation of his order, then he will handle the 6th one. Similarly, another one completed, he will handle the 7th one, like that. But fixed number of chefs are there in restaurant. There is no one chef for one order. Chefs are fixed, and only they will handle all the orders. And some orders will wait, new orders will wait. For example, if all the chefs are busy, that's a called fixed number of pool. So it creates a fixed number of threads. This is, it is when you have some few, or we can say, if you have what word I can use, I'm not getting it, but okay, some kind of parallel threads you have. When you have some controlled number of parallel threads, that's better. If you have any control number of parallel tasks are there, then we can go for fixed thread pool. It is good for executing controlled number of parallel threads, parallel tasks. That's the second one. Second type of executor. Third type of executor is called cached thread pool. It will reuse existing threads and as and when needed creates new threads. So this is the most popularly used one. But one issue is also there. Thread creation. If the threads are not needed, then they are going to be destroyed. If they are negligible, then this is a good one. Because it will create the new threads whenever they are needed, as needed. Right? And of course, reusing existing ones is also there. But along with reusing existing ones, it also creates new threads as needed. That is called cached thread pool. So executor service is equal to executors is a one utility class dot new cached thread pool. This is the other way of creating executor. Executor service. Executor service is the important interface. It extends executor. But directly we don't use executor interface. Always use executor service only. Executor service executors dot service is equal to new cached thread pool. That is one executor. It's a one type of executor. So it is going to create the threads as needed and also reuses existing threads. So mostly this is going to be used. Creates new threads as needed and also reuses existing threads. All right. That is called reuses existing threads and also new threads are created as needed. All right. So that is what the cached. That is a third. And there is one thing that is called scheduled thread pool. This is the last other way of creating the executor service object. Nothing but another way of creating executors. And this is basically, I mean, when you want to schedule the task after some delay, some time. So then it is going to be a good one. Okay, means the task should be executed, you know, for every 3 seconds or for every 4 seconds. Such kind of tasks are there. I have 5 tasks. Each task should execute for every 10 seconds, or one task should execute for every 4 seconds, and one task should execute for every 1 hour. And like when you have something like monitoring applications, like how much sales happened, the task is find out the number of customers newly added in these 2 hours of time and how much shopping they did. That is a task. That task should be executed for every 2 hours. Means for every 2 hours, I want to monitor how many new customers have did the shopping and what is the average amount they spent for the shopping in these 2 hours to analyze the customer's trend and also like what type of products they are shown interest viewed mostly over a period of one thread is calculating the average money spent by customers, the new customers in this period of time, and other thread is the most viewed product in these 2 hours. Okay, or most sold out product in the last 5 hours. So this kind of monitoring, like that, if I'm creating 2-3 threads, one thread should do this for every 2 hours, one thread should do this for every 5 hours, one thread should do this for every 24 hours. Such kind of tasks. These are called scheduled tasks. So for them, this scheduled thread pooling executor is good. That's a fourth category. Like that, there are 4 types. Now, the fourth statement is executor service. Service equals to executors. That's a utility class which contains all the static factory methods. New scheduled thread pool up to, I can give number like 2 or 3 like that. So this is when you want to execute the task or when you want to schedule the task at some intervals, at some fixed delay or intervals. Okay, or it is good for some repetitive tasks, like for every 2 hours do this, for every 4 hours execute the same task, but after 4 hours again next after 4 hours, like that. If you want to repetitively execute the same task, and the task also should have some delay. A delay could be even seconds also, but just I'm telling hours or minutes or seconds, whatever. So then this type of executor is good for that. Like it is schedule is very simple, like you are putting alarm and you are scheduling it. Okay, if you put alarm like every day morning at, let's say, 6 a.m. So that is a schedule. So alarm will ring for every 24 hours again at 6 a.m. every day. So that is like a kind of schedule. That's a schedule. You can define multiple schedules. One alarm you want to keep at 6 a.m. and other alarm you want to make it, let's say, for example, at afternoon 4 p.m. Okay. So if any such kind of you want to keep them, then you can go for this kind of at a fixed interval. So I can say creates new threads. I can say create new threads. Otherwise, okay. It is used when when you want to execute tasks, or when you have, okay, when you want to execute, okay, when you want to execute scheduled tasks, better. Scheduled tasks. Repeated. When you want to execute the scheduled task repeatedly, with a delay, like, or at fixed intervals, every 24 hours, every 2 hours, like that. At fixed intervals. Okay. Now, after knowing about the types of executor, there are 4 types of executors. One is single thread executor, fixed thread executor, cached thread executor, and scheduled thread executor. In short, we use the names like that, but methods names are okay, but you need to remember the methods names as well. But actually, single thread executor, fixed thread executor, cached thread executor, scheduled thread executor. Types of executors are 4. Types of executors are 4. Now we got how the 4 types of executors can be created and when it is good to go for what. Now how to submit my task. If I want to submit my task, I can call either execute method or I can call submit method. How the task can be submitted. Execute is one way, submit is other way. Execute and submit. The task can be submitted. Suppose I have a task and this is the task I want to execute in a thread. So I have to submit my task to the executor. It will create the thread. It will execute that thread. It will execute my task in a thread. It will take care of creating the thread, starting the thread, stopping the thread, synchronizations, everything. Just I need to provide my task. That's it. I am only responsible to provide my task. That's it. But if I want to submit my task to this executor, that is executor service object, there are 2 methods available called submit and execute. So here you are going to see the difference between runnable interface and callable interface. So the question comes here, how to submit my task to the executor service. How to submit my task to the executor service. So the answer for this question is we have 2 methods. One is void execute. Return type is void. It doesn't return anything. Execute and you should provide runnable object as parameter. That's a runnable. And what it will do, you provide the runnable, your task in the form of a runnable object to the execute method of executor service. It will take care of executing it. It doesn't return any result to you, but the task will be executed. And similarly, we have something called a submit. Submit means 2 methods are available, but submit method returns a future object. Basically, it is for asynchronous communication. We'll see. It takes callable parameter, not runnable. It is callable. Like runnable, we have callable interface. But there is a difference between runnable and callable. We will do that. So that difference I'll explain. Then you will come to know what is future. Then next we'll see what is completable future. That's it. That's a part of our session. So we are coming in a step-by-step process. Runnable and callable, both are having a difference. Runnable is also used for submitting the task. Callable is also used for defining the task. Runnable and callable both are used to define your task. But runnable has run method. It can't return any value. And it does not throw any exceptions. Because run method syntax, public void run. It has a run method, which is function interface, which has a only run method. Public void run. Runnable, callable, both are function interfaces only. We can use lambda expression to implement it. We can define a lambda expression to implement this runnable or callable as well. Runnable has a run method. Syntax is public void run, and it does not have any parameters. It does not throw any exceptions. Callable has a call. It can throw exceptions. At the same time, it can return a result of type T. It can return the result of type T. So runnable and callable both are having a difference. We have something called runnable is a very common one that we all know earlier. Runnable is an interface which contains abstract method called you have to define your operation inside the run. Return type is void. It cannot throw any exceptions. Similarly, we have something called as it is a function interface. We know that. Now, similarly, we have something called as callable. This from java.util.concurrent package. Executor framework is completely from java.util.concurrent package. It has one abstract method called call. It returns a value. It's not void. It can throw exception. It will return the computed result. And also it can throw exception if it is unable to compute the result. So there is a difference. This is also function interface only. It is callable. The previous one is runnable. So runnable and callable are having a difference. Runnable has a run method which cannot return any result and it does not throw any exception. And callable, it will return the computed result. And if it is unable to compute, will throw exception. That's the difference between runnable and callable. I'll write like a point. Runnable and callable are the functional interfaces. Runnable and callable, both are the function interfaces. Runnable's nature is fire and forget. Means does not return any result, okay? Doesn't throw any exception and does not return any value as well, okay? So runnable and callable. So runnable, or runnables method I'm writing. Runnable's abstract method. Runnable's abstract method is void run. And callable abstract method is its return type is V, method is call, throws exception. So the point we can write is runnable does not return the result, the computer result, whatever, if any computations are done, does not return the result. Runnable does not return the result and does not throw any exception. But callable returns the computed result. If unable to compute, it will throw an exception. If it is unable to compute or if unable to do so. If unable to compute, then throws exception. There is a difference between runnable and callable. Both are functional interfaces. There are two methods available. These are way how I can able to submit my task to executor service. One method is execute and other method is submit. Okay. So it returns future object. So basically submit method will perform asynchronous communication. Means if I call submit method, I can just go and have my task. Later when I get the result, I can get the value from future object. So I mean to say that like I can give the order in Swiggy, but I no need to wait until I mean I no need to sit idle until I receive the order from Swiggy. I can first give an order in Swiggy, then I can watch my TV. I can continue my work. Right? And whenever they deliver the order, I will receive the order and I will eat. Which means it is called asynchronous. Means it is not like if I give the order in Swiggy, then I need to wait. I should not do anything until the Swiggy deliver the order for me. I should not do anything. It's not like that. Okay, I can just give my order and I can watch my TV like that. And that is called asynchronous model. It is not like a synchronous model. You called, so you have to wait. Don't do anything until the response comes back. You should not do anything. You are unable to do. You are not permitted to do anything. It's not like that. So that is called synchronous model. So future object represents basically the result in future. Okay. Future object represents the result that is going to be generated in future. That's called future object. So whenever we call the second method that is called submit method, it returns a future object. So this future object I can use for my next, like whether my task is completed or not, I can find it later. I can just see whether task is completed or not, or whether result is ready or not. If it is ready, I can get the result from the future object. So future object is a handle for me, and through which I can check whether the task is completed, result is generated. If generated, I can get the result. Right? That is called future object. Future means future represents the result that is going to be generated in future. A future object is, it is an object which can hold the data or the result that is computed in future, that is going to be generated in future. That is called future object. Then we'll understand what is completable future. But let's see how we can write a code on this. Execute and submit both are having a difference. Execute is a fire and forget model. Fire and forget means just submit the task, leave it. It will take care. You will not get back anything because return type is void. Because return type is void. That's why it is fire and forget. But the submit is not like that. It's going to return a future object. You can retrieve the result from the future object. So execute does not return any result, but submit will return a result. That result we can retrieve through future. And it is asynchronous model. Execute is also asynchronous model only. Means I can call execute, I can do my work. And that execute will take care of the task execution. But after the task is completed, I cannot get back the result. But here I can get back the result in submit method. So there is a difference like that. The task can be any task, and both are functional interfaces. So we can use Lambda expressions to implement it. Okay, let's see. Kind of a small example may help you to understand. Let's see. Write a small code. Just only main method I will write. Inside the main, I will try to write my code. Just what I'm saying is I'll create one executor object that's called executor service object. Any one single thread executor, otherwise fixed thread pool executor, whatever it is. Then I will just define a task and I'll submit the task to the executor service. And it returns me future object. And it returns me the future object. Okay. And this future object is a handle for me. Later, I will continue my work. Later, whenever I need the result, I will get the from future object. but I need to wait for the result. That result may come after some time, but up to that time, I no need to wait. I can continue my work. So let me simulate such kind of example. Let's say, for example, it's a future demo. It's a future demo. I'll show you that how it can work. I'll tell you. I'm writing a future demo. Let's create some simple package. Some package, what name that you want, you can write. I'm simply writing pack1, and just I'm writing one new class, and class is test. It's a test class. So here is what's the logic I'm writing, you can see. So I wanted throws exception because I'm going to call sleep method. So sleep method throws interrupt exception. That's why simply I'm writing throws exception for the main, because interrupt exception is a checked exception. If it is a checked exception, then Java compiler is going to first check whether you have a try catch blocks to handle it, or at least have it declared it with throws. Otherwise, it will generate a compile time error and it will not allow me to run my code. That's why I'm writing throws exception here instead of writing try catch blocks. See, first I'm creating executor service object. So executor service, let's say executor equal to executors dot. These are all from java.util.concurrent package. Let's say new fixed thread pool executor of 2. Actually, one thread is enough for me, but still I'm just creating something new fixed thread pool of 2. These are all from this package, java.util.concurrent package. Executor service and executors both are in the same package called java.util.concurrent package. From the same package, java.util.concurrent package, you guys need to execute the executors and also executor service, both of them. That's called executor service. And now I'm talking about callable. Some task we can do. Task could be something, it doesn't matter. Callable is a generic interface. Okay. Let's say callable of string. Callable of string. Let's say my task is equal to, or callable is equal to anything. I took the name task. And why I'm taking like this is I want to store the lambda expression into this reference variable. Callable has a call method. Call method has no parameters. No parameters means my lambda should start with empty arrow token, because callable has a call method. Callable interface abstract method is call. It does not have any parameters. So my lambda expression starts with empty. Should return some result of type v. Here the value type I took is a string. Callable of v. The v value type is a string. It should return some string. Okay, I will write some body. The body is, the task is first have a sleep time. Have a sleep time for duration in, let's say 3 seconds or maybe 5 seconds, 5000 milliseconds. Then return hello dot to uppercase. That's it. Just I'm writing small code. This is the lambda expression. Of course, this is the body. And if you want to understand it clearly, you can just keep the code like this so that you can feel better. This is the lambda expression. Callable of string task is equal to, this is the call. It should return the value. Because return type is V. V is a value type is a string here. It should execute the task and should return the result. And during that, if any problem occurred, it will throw an exception. So return hello dot to uppercase. That is callable of string. Now I have defined my task. Now this task I can submit by calling submit method of executor service. Executor dot submit, which returns a future object. So future of string, the type is string. Let's say result is equal to, or future is equal to executor dot submit of task. Here is a submit method I'm calling. I'm calling the submit method of executor, which returns a future object. Actually, it is the task's completion will take at least 5 seconds time because of 5000 milliseconds duration I provided in sleep. It definitely take at least 5 seconds. But I don't need to wait for 5 seconds. After 5 seconds, result will come that will be stored in future object. But I'm just going to continue my work. I'm continuing my work. I'm continuing my work. I'm continuing my work. Yes, I'm writing something, which means I'm not waiting. I'm continuing my work. Later, when the task is completed, the result will come and store in future object. Now I can get the result by calling get method of future. Future as a get method. I'm continuing my work. SOP. My work is completed. Or if you want any statements, you can write. I'm continuing my work. My work is completed. Now I want to check for the result, the computer result. So I can get it system.out.println, the computed result, print it, future.get method. By this time, suppose if it's still not completed, assume that. By this time, when I call get method, still by this time, future object has not having any data. I mean, the result is not available in future because the task is still continuing. Then whenever I call the get method, then here the control will wait because get is a blocking operation. Blocking operation, I mean, it will fetch the result if it is already available in the future. If not, it will wait for the result. So get will stop there. After this get, next if any next statements I've written here, for example, if still result is not available in future, so these statements will not execute, nothing but the control is halted here, blocked here. This work is completed, but still the future is not ready with the output, is not ready with the result. Still it is not ready with the result. So if it is not ready with the result, then this get will makes the thread to wait because it's a blocking operation. So if a result is available, okay, get will fetch the result from future and will continue the remaining work. And suppose if I want to tell the executor, you just execute whatever the tasks which are submitted already, and it should not accept any new. It should continue executing the already submitted tasks, but should not execute the tasks that are going to be submitted next. Then we need to shut down the executor. Whenever you shut down the executor, its meaning is the shutdown method of executor service will initiate shutdown. Previously submitted tasks are executed, but new tasks will not be accepted. No new tasks will be accepted. You can see the message here. But previously submitted tasks are executed. Previously submitted tasks are executed by the executor service, but no new tasks will be accepted. Okay, that's what the meaning of shutdown. Means once a shutdown is called, executor service can continue previously submitted tasks, it will execute, but it won't accept any new tasks. If you again call executor dot submit, it won't execute. That new task will not be executed because already shut down. After this line, after this call to shut down, next any submissions will not be executed by the executor service. But shutdown doesn't mean that it is going to shut down immediately. If any tasks are still working, it will continue executing the previous tasks. For example, to the same executor, here I'm submitting one task. Let's say I'm creating task 1, task 2, task 3, task 4. 4 tasks I'm defining, and I'm submitting task 1, 2, 3, 4 to the executor service. If I'm submitting task 1, task 2, 3, 4, 5. So let's say, for example, task 1 completed just within 2-3 seconds only, but task 2 is taking 10 minutes. Task 3 is completed in 5 minutes. Task 4 is completed in half second. So because task 2 is still continuing up to 10 minutes, this shutdown is not meaning that it's immediately shut down. Just execute the previously submitted tasks, but no new tasks are accepted. That's what the meaning of shutdown. Now, let us run this code. So I got the 2 statements. I'm continuing my work. My work is completed. After 5 seconds, I'll get the future answer. The computer result is hello, because I'm writing hello.to uppercase. The result did not came immediately. And at the same time, once a task is submitted, the control is not waiting here to complete the given task. To complete the given task, if it is waiting at line 19, then I will not get this line 21, line 22 response immediately. But what is happening here? Once a task is submitted, the thread is taking care of that. My current thread is going to continue. It is not blocking. It is continuing its work. This is called asynchronous communication. Asynchronous call. When you call the submit, then the task will execute and your current thread will continue its remaining work without waiting for the submitted task completion. And the result, whenever it is available, it will be stored into future object. And from the future object, whenever you need the result, you can call get method and get the value. If still the result is not available, then whenever you call get method, we'll make the current thread to wait until the result comes from future. And shutdown method purpose is whatever the previously submitted tasks are there, you just execute them, but no new tasks are accepted. It's closed. Closed for new tasks. It is just only going to execute whatever already given tasks. That's all. Okay, that's what the meaning of it. It is just like, the last minute order of a restaurant. Okay, 11 o'clock, restaurant has to close. They will shut down the doors. But inside the restaurant, whoever the customers are already eating and whoever have already given orders before 11, they came into restaurant. So for them, food will be served. But they won't accept new customers because time is over. 11 o'clock is a closing time, like that. The concept is same like. Here we got the future object. It is a sample code for you, and import statements you will get automatically, nothing to worry. So what a future object represents? A future object represents a future object is to hold. Future is actually an interface. Is an interface from Java 5 plus. It is not now even from Java 5 only. Completable feature is Java 8. But future interface is from Java. Computable feature class is newly from Java 8. Is an interface from Java 5 plus. And it is to hold the result of a task execution or the result of a task. It is to hold the result of a task that is going to be generated in future. Going to be generated in future. Is an interface from Java 5 plus, and it is used to hold the result of a task going to be generated in future. Going to be generated in future. That is called future. It is to hold the result of a task going to be generated in future. That is called future object. Okay. So let's see the code, example code. Better if I give the code like this. Okay, that's how it works. Now we want to understand our concept from Java 8, and that is called completable future. Okay. As you know, completable future, it implements a future interface. And future is only for asynchronous, but this is for non-blocking. That's a new feature added in completable future. See, when you call future.get, as we discussed just now, okay. Now,
Now we are going to just see what is completable future. When you call get method, future.get, we have written the compute result is future.get. So as I said, it will block the thread there. For example, if a result is not available, if a result is available, it is okay. Until the result was available, it will block there. That's a blocking behavior of a future. Right? And it will throw exception. For example, I create some if condition here. For example, if the string does not contain 5 letters, throw one exception. But how to handle that exception? I should write again try catch blocks to handle that exception in this code. Suppose the string has only has 5 letters. My requirement is if the string has 6 letters, then only convert into uppercase. Otherwise, throw less length exception, something. Convert into uppercase if the string has more than 6 characters. If not, then throw an exception, short length exception, something like. Then how to handle them? To handle that, I need to keep the code in try catch blocks. Let's say we are in main method. I should keep my code in try catch blocks to handle it. Okay. So this type of issues, like mainly to avoid this kind of blocking behavior and also provide a way of handling exceptions, then we got a class given called completable future. Okay, so there is completable feature is non-blocking, and it has some mechanism to handle the exceptions built in. We can easily handle the exceptions without writing try catch blocks. There is a method exceptionally method is there. With that, we can handle it. That is called completable future. So of course, in completable feature, there are new methods provided to make it non-blocking and also to handle the exceptions easily without putting try catch blocks. Okay. So what completable future has given mainly, you know, one method is supply async. That's an important method. It is to run the task and return the value, like submit method here. Then completable future class has given one method called supply async. It is to run the task asynchronously and to return the value. Okay. There is a method available called then accept. Actually, what is happening here? Future.get returns result. But if I want to do further processing on the result, I have to write again separately manually. Suppose I got future.get means what it is going to tell me some result like hello in uppercase in this example. I will get a string. So I'll store in a string and then I will do some processing on that. But here what I can do, I can call then accept method to process the result. So there are two methods, supply async, multiple methods are there. One method is supply async that will create a completable future object instead of future object. And now completable future will internally take care of creating executor service and all. Here I no need of creating manually executor service object in completable feature. That is a more advantage of completable feature. I no need to create the executor service object separately, and I just simply call it will take care of creating the executor service internally. So there is a method provided called supply async. I will tell this is a task I want to run asynchronously. and return the value. Okay. And once value is ready, then do this task on that result. It may be display or it may be doing some other operation on the result, whatever it is. And it is also asynchronous operation. No need to wait for completion of that task. It is non-blocking. It is non-blocking. And we don't have manually creating executor service object like in this example we did. And if a result is available, we can say what to do with the result, whether you want to print it or whether you want to do some other action on that when the result is available. But it is not blocking operation. If a result is not available, the task will not be executed. Whenever the result is available, it will execute. Till that moment, it will not execute. See how it is going to be different. Then I will write the statements with respect to completable future. Okay, see the same kind of example I will write. You can see to get an idea. The thing is, no, we are not going to create executor service object like how we created for the last. Let's say I'm creating a new class called main class. And here is my main class. And here I'm just writing. First, I need to pass my task. I should pass my task and task. There is a method called supply async in the completable future class. You can see this. Again, I should pass callable object only. So there is a class completable future from Java 8. And it has a method called supply async. This supply async method takes supplier object as parameter. Supplier is a supplier of data. It doesn't accept any parameter but returns a result after doing some action. It is called what I can say functional interface. Its return type is T, method name is get. I told 4 interfaces you must have thoroughly on mind. Return type is T, returns a result, but method is get. It does not accept any parameters. It has 0 parameters.
Yes.
This is called one functional interface. So here to the supply async method, I should provide my I should provide the object of type supplier, means a lambda expression I should provide which is matching with this functional interface as an implementation of supplier, not the callable. It is supplier. So with return type is a T and it is get. And supply async is overloaded method. It has supply async of supplier and executor. I can also, if I want to explicitly create an executor and if I want to pass it, I can also pass it, but no need. It will take care of. Unnecessarily, we don't want. We don't want. This is called supply async method. We should pass supplier. It's not callable. So supplier does not accept any input but returns output. Means the task you can write and return some result. You can define the task and you can return the result. So let's say simple example we'll write with hello. Again, I'm saying throws exception. Later, I will tell you how to handle the exception also. Because to particularly explain that, okay, it is asynchronous communication, I should make at least some time to sleep because the task execution is going to take very nanoseconds time. So then we can't understand that it is working in asynchronous model. That's why I'm just trying throws exception. Later we'll see with handling exceptions with exceptionally method of completable future. completable future. Just we'll straight away forward with hello world. Let's say future is equal to completable future dot supply async. So supply async takes supplier. Okay. The task I should provide as a supplier. Otherwise, I can also define the task in supplier reference and I can pass the supplier reference. Why not? That is also okay. But we know that's why directly we are providing the lambda expression as parameter because it's a method accepting a functional, an argument of type functional interface. So we can pass lambda expression. So arrow token, let's say hello world. Otherwise, it should return some result. So I'll write the body because to know about it is like spanning for. I'll write in the body like this. I'll write the body like supply async of this one. Thread dot sleep of 5 minutes. Sorry, 5 seconds means 5000 milliseconds means 5 seconds. Then return hello world. Then I want to close it. Then I want to close it. That exception we can handle with exceptionally, otherwise rows exception, but it is a statement we are writing in lambda. It is saying that unhandled exception of type interrupted exception. Okay, I will do one thing. Currently, I'm not typing about exceptionally. Don't worry. I'll define my own sleep. This is the method which I'm creating by myself. Or instead of making it complicated for you, initially first what I will do is, okay, I'll call the supply async. I'll come back. But before that only, I'll complete supplier. So supplier of string. Let's say supplier is equal to arrow token thread dot sleep is the first statement I want, right? Of 5000. After that, return hello world. Okay, now this is good. And here I'll pass supplier. Okay, that's better now, as of now. Okay. Again, it is saying that thread dot sleep is unhandled exception of type interrupt exception. Okay, public static void method throws exception, but this is going to execute inside this asynchronous model. That's why it will throw.
The try can.
Just a minute. I'm thinking a separate solution for this. What solution I want to do is I can add this statement in try catch blocks. That is also good, but if I write inside my lambda expression again try catch blocks means it is not going to look good. That's why. Okay, I'll do one thing. I have a solution. What I will do, I'll only call sleep. Actually, sleep is not predefined method. It's my own method. So I'm creating one more static method called sleep, which is going to accept milliseconds as parameter. One private method I'll create, private static sleep of milliseconds. I'll take into milliseconds or whatever, or long milliseconds, anything, long ms. And here I will write try thread dot sleep of that ms. Catch that interrupted exception. Interrupted exception. And nothing. If you want display the exception, you write SOP of EX. That's better. Now I don't have any error. Nothing is there. Instead of writing try cache blocks here itself, this is not predefined method. It's my own method. This sleep method is not predefined method. This sleep method is my own sleep method. So whenever I call sleep of 5000, the control will go to this method. The control will go to this method. It is my own method. Instead that I am calling sleep again by keeping the code in try catch. So hope you guys have understood about my logic. That's what I am doing. Otherwise, I cannot here only thread dot sleep, but I have to put the code in try block and catch block. So it's going to look odd here. That's why I have created one separate method, sleep by myself as a private method. And so control goes to this sleep. This sleep of my own sleep method is internally calling sleep method of thread class only. So here I am writing try catch blocks because it's in separate method. So my lambda expression is not looking ugly. That's what the point. So now what I will do here, I'll do one thing. What I'll do is SOP. I am continuing my work. I'm continuing my work. Okay. Then I write, if for example, available, future has the result available, then previously we called get method. But by that time, if it is not available, if still the future has no result available, then the get method will make it to wait there. It will block there. But now completable future is not like that. I'm continuing my work. I'm writing like this. What? Future dot then accept. Then accept method takes consumer as a parameter. What I do is something. Perform this operation on the future object. Result. Otherwise, directly system.out.println of result. System.out : println. See my statements. To make it clear, I'm writing spaces. SOP I'm writing, still my work is going on. Still my work is going on. So still my work is going on. SOP, I am done. I'm done with my work. Some statements I'm writing like this. The meaning is, actually first it is printed. But by the time when it comes to this place, if it is normal future object, if it is not a computable future, we have to call get method. But by that time, if the result is not available in that future, that get method will hold the current thread to wait there only until the result is available. After that, then the thread can continue executing the remaining work. But here it is not future, it is completable future. So if it is completable future object, then it will not block the thread. It will not block the thread. When the result is available, then only this then accept method will execute the task. And it doesn't make the thread to wait here. When the then accept method is called, if the future object, completable future object is not available with the data result, it will not block the thread. Okay, it will allow the thread, okay, you go and execute your remaining code. Whenever the result is available, I will execute this. You don't need to wait for this, you continue your work. That is called non-blocking. So that's a difference between the previous future object and this current one, that is called completable future object. Let's execute this. See, I'm continuing my work. Still my work is going on. I'm done with my work. Later, I'll get hello world after 5 seconds. It's a private method called. It's a milliseconds, 5000 millis, return hello world. It's a string. System.out : println. It should print it. But it's not printed now. Am I getting anywhere hello world? No. I'm continuing my work. Still my work is going on. I'm done with my work. But my result is not printed. It should print it actually. System.out : println should print my result. The result is hello world. I should get the work. I should get the output called hello world. Okay. Let me do one thing. Yes, now you can see hello world. The reason why previously I didn't get hello world and currently why I got hello world have a difference. Because once this work is completed, line number 22, main thread is closed. If a main thread is terminated, then I can't able to see the result that is coming from this completable future. That's why what I am telling the main thread, you wait. Okay, you wait. You wait means what? I am going to join this current thread. The current thread is main. Okay, I am joining the main thread with main only. Same thread again I am joining to itself. What I am telling, until the main thread is completed, you should not shut down. That's what the meaning of writing this statement. Okay, you have to continue until the main thread execution is completed. Means I'm telling the main thread until the main thread execution is completed, you should continue. This is little bit tricky, but more multi-threading skills required to understand this statement. More multi-threading skills required to understand this. Okay. So then we can able to see our response. Now we can see I am actually calling here in the middle, then accept, then display the SOP statement. But I got the response. Still my work is going on. It is not blocking me. It is not blocking. It is continuing me to allow to do my remaining work. I am done with my work. After that, I got the response called hello world. So if it is a future.get method, then it will block here only. You will not get the remaining 2 lines output until your result is available. But here this is executing later. It is not blocking your thread, current thread. It is still allowing the thread to continue the remaining work. That is called non-blocking operation, not a blocking operation. That's called non-blocking operation. Okay, right. So you have to understand yourself about how this join is working. It is simply one statement. I'll tell you that I'm joining the main thread with main only. I'm joining my main thread with main only. Okay. So there are completable future methods. Now, for example, you want to join for example, you have 2 tasks now. You want to chain them. You want to chain them in the sense what? You have, for example, one completable future object and its output is required for another next completable feature of task. Okay. If one task is depending on other task, you have to do chaining of the task. That is possible with completable feature. There is a method available called then compose. See, what is the point I'm saying? I have one completable feature. I can combine them together. There are 2 completable features are there. First feature, if it is completed, its result is required for executing the second completable feature. Means first object is performing task 1, second object is performing task 2. But task 2 depends on task 1 result. Task 1 result is required for task 2. So then we can combine or we can chain the completable feature objects by using then compose. I will add the statements later, but first let me quickly copy this code for you. This is the example by using, this is future object example. This is example through completable feature class. There are 2 methods I have written here. One is supply async method and next one is supply async and the other method is then accept. Now, then compose is there. That is for chaining the dependent features, chaining the completable feature objects. Simple. One task depends on another. What does it mean? First, I should do the task 1, then the task 2, because task 2 need the result generated by task 1. Then I should combine them as a dependent task. One after the other should execute. And for that, we have to use a method called then compose, chaining. That is called chaining concept. Like then accept, then chaining, then compose for chaining. Let's see. After that, the result will come in again another completable feature object. Now you can simply do some work whenever the result is available in the completable feature by using then accept. So I have task 1. I'll supply the task 1 to one completable feature object. Task 2 depends on task 1 result. So then I should combine. Task 2 with a task 1. So once a task 1 completed, I'll get a result. That result I will use in task 2 in the second completable feature. So there are two completable features. Each of them should execute 2 tasks, but task 2 need the result of task 1. So then I should combine them together by calling then compose. They are called chaining of the 2 tasks. A simple example we will see. A simple example we will see so that you get clarity on this. Let's say, okay, let's create one more example without disturbing this code. And if I write inside this also, may get confusion. That's why let me use then compose code. Let's create a demo class. Look at this. I'm just going to complete it now by using how we can combine the two completable future objects into combined one. Okay. If they are okay, we can also combine. Okay. Suppose if there are two independent tasks are there, result 1 comes from task 1, result 2 comes from task 2. There are two compatible feature objects. Now we want to combine the results of the 2 tasks. Then we can combine future 1 with future 2 and we will get a combined future, and then we will get the result from combined future. So there is an operation called then combine. We can use it to combine the two either dependent futures or independent futures, anything. Let's say, for example, first let us see how we can combine the two independent futures. We can combine the future 1 with future 2. Let's see how it can be. I have to create a class actually, not the project. Inside the pack 1, let us create a new class. It is demo class I'm creating with main method. Look at this. First, I will explain. Something like this. Let's see the code quickly. I need to leave actually. Still it is dragging. It is getting late for me, but still see. My requirement is just I'm thinking about how to give an example which is related to two. We will get the two computable feature objects and we want to combine them together. They are two independent tasks. We will combine them together to make a single one. Okay. See how it is in the real-time cases, like I want to create one completable future object to get the user profile data. Another completable feature object for getting his order history. Whenever a user has logged in, I want to get his profile data, and also one task is get the profile data of this user, and other task is get his order history, whatever the orders he has given previously, all the data. then combine both of them and give like a single result. You got my point? So one task is get the user profile data whenever a user has logged in. One task is get the profile data. Other task is get the order history. Here there is no dependent. Profile data and order history both can work independently. Order history task, no need to wait for profile task. Profile, fetching the profile data, fetching the order history, two can execute independently. But after getting the profile data and order history, combine both data together and make it like a single data. So that is a example you can understand of what is then compose. Mostly we use then compose for that. So let's see how we can simply create one sample example of how I can work with this then compose. See here. I would like to, I would like to explain how I can use then compose. Two completable future objects I'll create. Let's say CF1 and CF2, two objects I'm going to create. CF1 is to complete one task independently. CF2 is another to complete independently. So directly I'm writing like this: completable future of string CF1 is equal to completable future dot supply async. And the supplier is very simple now. Let's say returns Ashok IT. My lambda expression contains a single string once, so it returns automatically. If there is a value, it will return the value. It's a string value, it returns. So this is a supplier which does not have a parameter, returns a string. This is CF1. Similarly, I'm just creating one more, that is CF2. And CF2 is to return technologies. Let's say it is Ashok IT and that is technologies. Okay, Ashok IT technologies. So we have CF1 and we have CF2. Then they are independent actually. The first supplier and second supplier. Now I want to combine them together to get like a single result. So completable future of string CF3 equal to, this is a way of combining. Then compose is a method. Sorry, then combine. Then combine the other one. The other future object is CF2. So CF1 then combine with the CF2, both are independent. And we should provide the second parameter. What is the functionality you want to apply by combining them? By function. By function means takes two inputs, applies the given functionality and returns a result. Like a function, we know by function. By function is another functional interface. Function, similarly by function. Function has apply. Apply method takes only t, one parameter, returns a result of type r. But here it takes t1 comma t2, returns a result of type r. That's called by function. So you should know by function, and of course I can directly open here by function. It is a function interface. So there is function interface called by function, which it takes there is a abstract method called apply. It takes T, U, two different types of inputs or same type of inputs, whatever, two parameters, TU returns result of R. Means it takes two parameters and the two parameters can be same type or different type. One can be T type and one can be U type, other type, and returns a result of some other type. This is called by function. Okay, so at least you are understanding something because of I taught these Java 8 features slowly one after the other. Otherwise, you can't understand. So let's say I'm taking R1, R2. The two inputs R1, R2. Let's say R1 is a result of CF1, R2 is a result of CF2. So it will apply this functionality by combining CF1 and CF2. R1 will be the result from CF1, R2 will be the result from CF2. Both may give same type of result or different type of result, doesn't matter. And what's the result to apply is just add them, R1 plus R2. We know strings concatenation. R1 plus R2. So another computable feature object is created by combining CF1's result with the CF2's result. This is the functionality applied on the results. Suppose CF1 returns Ashok IT, CF2 returns a string technologies. So this is the result of CF1, say Ashok IT. This is result of CF2 technologies, R1 plus R2, Ashok IT technologies. Then I say, I got the third computable feature by combining two, CF1 and CF2. Now you can just apply, you can call then accept and then print whenever the result is ready. CF3 dot, then accept and system dot out colon printer. Do this action. So system dot out colon printer. So basically this combine is merging the result of our first one and second one. If once CF1 and CF2 both are completed, now it is going to merge these two by applying the given function. It is going to merge the two independent futures when they are completed. We have to use then combine for merging them and creating like another new future object. And whenever this future is ready, then we can able to do the action once the result is available in third future by calling then accept method. It will execute the given consumer once the CF3 stage is completed. These are all completion stages. Now result will be same. Ashok IT technologies, but the understanding point is then combine. It is used to combine two independent computable features together and applying some functionality on the results of CF1 and CF2. Then we have to use then combine. The combined result will be there in CF3. And now you can just do something on the result of CF3. You can print it or you can convert into uppercase and print it, or you can convert into lowercase and print it. That's up to you. Or you can just print the length of or count of characters, whatever it is. So response is Ashok IT Technologies. Okay. So I can't spend more than this now. Need to leave. There is one more small point is that tomorrow I'll explain nothing. how we can handle the errors using completable future. And by the session tomorrow, I'll take some time today to add some statements related to streams, operations, and this completable future. And we are going to have discussion on what is local date and local time classes. Tomorrow, just I'll give a brush up of what is I'm going to give a view of what are the classes, and then we will have an introduction to what are the features that are there in Java 17. While talking about Java 17, whatever the finalized features of Java 16 are there, like record class or any other finalized features are there, like using instance of for typecasting. So those kind of finalized features also will be covered as part of Java 17 only. Java 17, we don't have any much features. So just in 1-2 sessions, I will conclude this batch. I'll conclude this new features topic. Monday and Tuesday, I'll take the sessions and complete. I'll try to complete. Okay. So this is my just then combine code. I'll put here. I will add the statements related to what is then combine, what is then accept, what is supply async. Those kind of statements I will add in the completable feature. Here is a completable feature example. Before this, I will write completable feature class definition. I will write what is supply async and what is then accept. And we have also used then combine.
Sir, in the previous
Or I will
example,
talk
you
about
have
what is exceptionally. Only these points I want to talk and nothing more else. So first let me copy the code, and that is the main class. I want to copy the code here. This is example with then combine. Okay.
sir, in the previous example, you are using the feature. Now we are using the completable feature. So then when we go for feature, when we go for complete feature, just about apply sync method or sync method for that.
Okay. So this is the code. So whatever the class which is given as completable feature, and this is what used now because of its non-blocking feature. That's it. Because of non-blocking feature. And another thing is, if you are working with future, you can get the data from future, but you have to take care of manually combining them together separately. But here it is non-blocking, and you have the option called then combine to combine the results coming from individual future objects. These facilities are missing in future, but these features are added in completable future. For example, when you log in into your banking portal, so one task is get your accounts data, profile data. Second is your loans data. Okay, third is your cards data. All should be displayed on the dashboard. Whenever you log in, your dashboard should display, hey, this is your profile data. Hey, this is your loans currently status, and these are data of your loans. Like whenever you log in into IRCTC, it will show your upcoming journeys details if you have booked for any tickets and all. So similar kind of thing. Whenever you log in into your banking site, your dashboard should be filled with your profile data, your loans data, your cards data, which means what? One completable feature is executing the task of fetching profile data. Another completable feature is executing the task of fetching the loans data of this user. And other completable feature object is executing the task of getting the cards data. So once all the data are available, then another future object is created by combining the data of the three futures, and that is given to the front-end application. The front-end application will show the data.
Okay.
So that's how it works. Okay, so we are done now. I have to leave. Okay, so I have some personal works to do. So that's it for, okay, for today. And
Are you
tomorrow.
sending